Yesterday we said when we're doing left and right transformations, x is a liar. So anything we do with x, we kind of got to think a little bit harder about. Left 3, I'm actually going to replace the x with x plus 3. And so what happens then is I put it in the parentheses, x plus 3 squared. Okay? And then the up 2, it's like you have to put it in the function with x. Okay? We take out the x and we replace it with x plus 3. So since we're squaring it, we're going to square x plus 3, and up 2 would be plus 2. Now, if you would take your graphing calculator out, this would be confirmed on the graph. Okay, doesn't that look like the parabola moved left 3, up 2? Good. Then let's talk about x-axis and y-axis reflections. When we reflect something over the x-axis, what did it say in your notes? It says y equals the opposite of f of x, doesn't it? Okay, and so what that means is this. This function, I take, and I'm going to put a parenthesis here, the opposite of the whole thing. Now, later on when you're seeing what this means, you don't have to show me that it's the parentheses, as long as you understand the opposite of an entire function should change the signs of all of these things. So this would be y equals negative x cubed, if I would distribute the negative, plus 2x squared minus 3x minus 1. I don't know where I put my little highlighter. Okay. So how does y-axis look different? Well, y-axis is a little different because you're going to actually physically replace every single x with a negative x. And in a second we'll graph just so you can see them. So I am going to take out, so we're going to do y equals f of negative x now. I'm going to take in the original function x cubed, I'm going to go negative x parentheses cubed minus 2 times negative x parentheses squared, make sure the parentheses are in there, plus 3 times negative x plus 1. Now be careful, remember your order of operations. We want to address the exponents first. And so if you're raising a negative number to an odd exponent, it's still negative, agreed? But if we raise a negative exponent to an even power, it becomes positive. Okay, so this becomes negative x cubed. This, yes, thank you. Be careful, because you might think, oh, that's plus 2x squared. Wait a second, negative x squared is positive, agreed? But that negative 2 is still there. How about the plus 3 times negative x? That becomes what? Yeah. I'm going to just, while we're still writing down, put the original function in. Arcus is first with the math test, just first on. All right, if I put in A, that should look like it's reflected over the x-axis. Oops, I'm going to just do that in below. So there's my original, and now reflected over the x-axis. Does that look like reflected over the x-axis to you? I hope it does. This went down there. This flipped up there. Okay. No. I mean, it does, but that's just a coincidence. All right. I'm going to type in the second one now and the original and see, just confirm that it looks like it's reflected over the y-axis. So there's the original graph. Okay. And that's reflected over the y-axis. So this went to there, this went to there. Okay. So now we're going to put some transformations together, and we're going to sketch some graphs. And I'm going to address what Molly was saying about can you do things in different orders. And really you can, I always say go left to right except with x, because x is a liar. And I'll talk about that. Doesn't even happen till letter C. Okay? So number 3A, state what transformations have occurred, graph without your calculator. Whoa. All right, so we're going to do A down here. Well, first of all, what is it related to? Yep, the cubing function. What's this 2 out in front? Vertical, it's out in the front of the function, vertical stretch of 2. And then moved 1 unit to the right. Okay. Just for a point of reference, what I'm going to do with a pencil is I'm going to lightly sketch x cubed, and then we're going to do those transformations. Let's try to do a scale of, like, go 5 each way. The x cubed graph goes through 0, 0, 1, 1, and -1, -1, and then it's kind of curved like this. So I'm going to use those 3 points as like my transformation points when I'm doing my new one. Okay. Why did I know 1, 1, and -1, 1? Well, is it 1 cubed 1? And is it -1 cubed -1? Okay. Now, could I do some other fancy points? Yes, but we're just doing a sketch, okay? So, a vertical stretch of 2. I'm going to tell you, a vertical stretch would multiply the y-coordinates by 2. What would happen if you multiplied the y-coordinate of 0, 0 by 2? Nothing would happen, correct? All right, and then I'm going to move it 1 unit to the right. So, it's going to move to right here. I'll do a different color. Let's do pink. All right, let's take a look at the point 1, 1. If I multiplied the y-coordinate of 1, 1 by 2, what would it go to? Just the y-coordinate. So this is the point 1, 1. If I vertically stretch it of 2, what it means is you're going to multiply the y coordinate by 2. Wouldn't it go to 1, 2? And then we move it over 1 unit to the right. So I'm going to stretch it up to 2, move it 1 unit to the right. Now it's going to move over there. All right, let's take a look at the point 1, negative 1. What if I stretched that 1 or multiplied that y coordinate by 2? It would go to 1, negative 2. So I stretch negative 1, 1 to negative 1, negative 2, and I move it 1 unit to the right. It's going to be resting on, yep. And then I draw my curve again. So I hope you can see from my sketch that that cubing part in the middle is stretched a little bit, but it still looks like a cubing graph, and it's definitely moved 1 unit to the right. And like I said, my hope is that you just can do maybe 1 or 2 little points. This is not like a tabling values and spending 5 minutes on a graph kind of thing. All right, absolute value. Let's do B. So what's the parent function that this one's related to? Y equals absolute value of x. Okay, what does this out in front mean? Out in front of the whole function.
X-axis.
Good, reflected over x-axis. Which means, think of the V. The V is going to be going down. And then we're going to move left 3, down 4. Okay, so I'm going to do, again, my little in pencil sketch of my V. And if you want to on this one, just kind of think of doing, because the V is not as complicated as an x cubed. We're going to reflect it basically over. And can we just, are you okay with me moving just the tip of the V? And then we'll just make it go down instead? Comfortable with that? Okay. So I am going to make the V go down. Let's move this vertex point, that's a vertex, we call that, left 3, down, 4. Okay. So instead of at 0, 0, we'd be at 1, 2, negative 3, that way, and then it's going to be going down. By the way, a V or an absolute value, those 2 lines that come in, they have slopes of 1. So if you wanted to be accurate, you just make them now have slopes of positive and negative 1 going the other way. All right, C. Yikes. Well, we know C is related to what? Okay. I am going to rewrite it for you in another way and see if you can see the transformation. And here's what I will tell you about this. I'm going to call this negative x plus 1. As you're looking at an equation, you may go left to right in the order of transformation. Here's where it gets a little tricky. When you're doing things with x, because x is a liar, if I would move a graph, let's think about this. If I would move a graph right and then reflect it over, it would be over here, right? But let's say I reflected it over first and then moved it right, it's not going to be in the same spot. So here's what I say. If you want to have like kind of a rule to do this, using the transformations like they look in the function, because x plus 1 we've said was a left one, right? Correct? I shouldn't say right. And this is a reflection over the y-axis. You are only, in parentheses with x, going to go backwards on them. So I am going to do this first. left one and do this second. Reflect over the y-axis. All right, now I'm going to talk about key points on here. Think of the square root curve. Isn't the square root of 1, 1? And you could do like the square root of 4 too if you wanted to for key points. But I'm going to just really do a sketch here, so I'm going to just use my 0, 0 points. Okay. If I would move that left 1, where would it go? Negative 1, 0, right? And then, so I'm going to move this, negative 1, 0, and reflecting it over the y-axis then, actually what happens? So right now, here's my point, here it is. Okay. If I reflected that over the y-axis, now where would it go? 1, 0, and it's going the other way. Okay. So that's what your graph looks like. We'll show you a graph on the calculator to back it up. So here's my question for you then. In order, can you list another transformation that would get to the pink graph? If I had done what first and what second. In my case, I did left one first, then I reflected over the y-axis. What is another set of transformations would get it to be the same spot? What if I had reflected first? What if I reflected first? Then it would just be still at 0, 0 going this way. Then I would have had to move it right 1. Do you see how the order of those two matters? You guys got to be really, really, really careful. If you want to list them in the order that they're shown, like how we think of them, I address this first, that second. But also, if you want to just look at the graph, that would be a perfectly acceptable answer. So sometimes the order matters of those transformations.